Welcome. In this lesson, we will be looking at measures of position, also called measures of partition. All right, so we look at the quartile family, the decile family, the percentile family, and the standard score, also called the Z-score. All right, I have referred to the quartile or all of these 1, 2, 3 as quartile family because they all rely on what we refer to as quartile in one way or the other. All right, so let's start. The quartile family. First of all, we'll discuss about the quartile. So the quartile divides a data set into 4 equal parts. So there are 3 quartiles: the Q1, the Q2, and the Q3, which are actually called the first quartile. So Q1 is first quartile, is the first quartile. Q2 is the second quartile, and your Q3 is the third quartile. Right? Now, how do you get them from the data set? So Q2, your Q2 called the median, actually divides your data set into 2 equal parts. So first part, the first part, and the second part. Now, so having known that, we can, look at your Q1 as the median of this part that you're seeing in cyan. That is, so then the part you're seeing in purple, you can take your Q3 to be the median of that part. So that means the Q1 is actually the median of one part, and the Q3 is the median of the other part. So and that happens when your median has divided the data set into 2. So let's look at that, or let's see how we can use the quartile. So the interquartile range now relies on the first and third quartile. So it's Q3 minus Q1, and that will give us 6 minus 2, that will be 4, because Q1 is 2 and Q3 is 6. All right, so the semi-interquartile range is 6 minus 2, and that and all of that divided by 2, so that will give us 2. Now, in the previous video, I said something about quartile, like interquartile range being A minus B. So that's what you're seeing here now. So similar to your range that says maximum minus minimum, and then you have the semi-interquartile range to be something like A minus B divided by 2. So your A is actually Q3, B is Q1. Now, so we go on to another example. Let's look at this. How do we obtain the quartile and the interquartile range and semi-interquartile range for the following data sets now? So we can do that by first obtaining Q2. And when we have obtained Q2, that will be 3.5. You know how to do that? I believe you should know how to do that by now. That will be 3.5. So the reason why you are doing this is because you have 8 observations. Is it? Okay, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so 8 observations, and 8 divided by 2 is 4. So the 4th and 5th observations happen to be 3 and 4. So you divide them by 2, and that will give you 3.5. So here the number of observations happens to be 9. So you can see that 9 plus 1 divided by 2, that's going to be 5. So you're doing 9 plus 1 because 9 is even. 9 is odd, rather. So you are doing 9 plus 1 because 9 is odd. So 9 plus 1 gives you 10 divided by 2, that will be 5. And so that happens to be, so the 5th observation is our median, and that happens to be 33. So you now have 4 observations to the left and 4 observations to the right. And so 4 divided by 2 gives you 2. So the second and third observations are important to you. So second and third observations happen to be 31. So you add them and divide by 2, you get 31. So Q1 is 31. Q3 happens to be the second and third observations in this part, so in the right part. So when you take the second and third observations and you add them and divide by 2, you get 38. So your interquartile range can now be obtained, and that will be Q3 minus Q1, and that happens to be 38 minus 31, and so you get 7. Do that again, your semi-interquartile range has to do dividing the interquartile range by 2, you get 3.5. So the next data set happens to be, so we have 10 of them, that's even. So 10 divided by 2 is 5. The fifth and sixth observation are of interest to you. So you take 8 and 9, you add them and divide by 2, that gives you 8.5. Then you happen to have 4 observations to the left and 4 observations to the right. And so that means 4 divided by 2 gives you 2. So 2, the second and third observations are of interest to you. So when you do that, you're going to get 4.5 you're going to get Q1 to be 4.5 and Q3 to be 13. And so you can obtain your interquartile range and semi-interquartile range just the way I've explained before. And so the last one happens to be 19, a data set of size 19. So 19 plus 1 divided by 2 is 10. So you have 10. The 10th observation happens to be your Q2, and that's 35. And then you have 9 observations to the left and 9 observations to the right. So, and 9 plus 1 divided by 2 happens to be 5. That's 10 divided by 2, that's 5. So the fifth observation will be your Q1 when you look at the observations to the left. Okay, so 1, 2, 3, 4, 5. Okay, so 28. 1, 2, 3, 4, 5, 50. So that's Q1. Okay, this will be Q1 and this will be Q3. So that's how you get your quartile. But then we may use another method, and that method is actually, okay, not another method really, but supposing we have an ungrouped frequency distribution, how do we obtain it? So, and in this case we have hundreds of, we have 100 observations. So how do we obtain it? The logic from what we just did can be used here without having to draw anything like we did here. And we drew things here, but we don't need to draw anything here. What we do, actually, all we need to do is just say, okay, if we have n to be odd, if n is odd, then we will have only one observation in the center. But if n is even, we'll have 2 observations in the center. So when n is odd, we can obtain Q1 by using n minus 1 divided by 2. Not that n minus, okay, so just what we are trying to say is that if Q, or rather, if n is even, for instance, then we need to remove the 2 observations in the middle, and then we'll have an observation, a number of observations to the left and a number of observations to the right. And what is going to be the number of observations that we will have to the left and the number of observations that we have to the right? That's what we are saying here. So the number of observations to the left and right would be n minus 1 divided by 2 for when n is odd. So we have n minus 1 divided by 2 observations to the left and n minus 1 divided by 2 observations to the right. However, if n is even, then we will have n minus 2 divided by 2 observations to the left and to the right. Now, so in this example, in the example we have here, n is even, so we are going to have n minus 2 divided by 2 observations to the left and to the right, and that will be 100 minus 2 divided by 2. That will be 49 observations to the left and 49 observations to the right. So, and our median will be in the middle. Okay, so Q2. Don't forget about that. Now that we now know the number of observations we have to the left and right, we need to get our Q1. So Q1 will be 49 plus 1, just the way we were doing before, divided by 2. I mean the element in position 49 plus 1 divided by 2, and that's going to be the 25th element. So go back to your frequency table and look at it. If you start from here, so the 25th element happens to be 28. So that means you'll be repeating 28. You repeat it until you repeat it 25 times. So the 25th time, you are going to have, so the data is something like that. So you continue 28, 25th time. Then if you continue listing the elements, 30 will be repeated 5 times. So you keep writing 30 until it's 5 times. So you continue, you repeat 35, 50 times, 20 times rather, this one. So that's just what we are saying. And so the 25th element happens to be 28, which is our Q1, okay? And instead of having to do or look for another way of getting Q3, we can actually use what we have done in our Q, or what we have done to obtain our Q1 here to obtain Q3. How? Note something, for instance, if we have the data like this, 1, 2, 3, 4, 5, 6, 7, and we want to obtain our quartiles. This will be our Q1, Q2, Q3. But if we arrange the data, if we arrange the data in descending order, this one is ascending order. So if we arrange this one in descending order, what we are going to have is that Q3 will be in position of Q1. Q2 remains in its position, but Q1 will be in position of Q3. So it will be in the position of Q3. So Q3 will be in the position of Q1. So I want to take advantage of that now to obtain our Q3. So in order for me to make the data be in descending order, what I'm going to do is that I will start from here. So it's more or less like I say, okay, let's do the data. So say 53, comma, I'll repeat 53 30 times. And so when I'm done, I'll repeat 40 20 times and continue like that until finally I will repeat 28 25 times. So that's what I'm doing here. So if we do that, then our 25th element actually is going to be 53. So if that is the case, then our Q3 is 53. Now that's that about that. Now going further, let's take another example. Obtain the quartiles for the given data. Now, obtain the quartiles for the given data. Now, having this, we can do the same thing because the number of observations here is actually odd. We just say 193 plus 1 divided by 2, and that's going to give us the 97th element. So the 97th element, going by our frequency here, you can look at the less than frequency. I obtained this, if you don't know, 30 plus 18, 30 here, then 30 plus 18 gives us 48, then 48 plus 48, 96, 96 plus 54, 150, 150 plus 43, 193. And then, so as so the 97th element happens to be 408. How? This is going to be the 96th element. So we are going to repeat 408 54 times. So the 97th to the 150th element will be 408. So definitely the 97th element is 408, and that happens to be our Q2. So going on, Q1 can be obtained by, we have just one element in the middle this time around because n is actually 193, and that is odd. So we just say 193, 193 minus 1 divided by 2 will be the number of elements we have to the left and the number of elements that we have to the right. So while our median will be in the middle, just one observation in the middle. So, but in the previous example, we would have two observations in the middle. So here we have just one observation in the middle. Now that we know that we have 96 elements to the right and 96 elements to the left, how do we obtain Q1? So we say Q1 will be 96 divided by 2 because it's even. So just the way you obtain your median, 96 divided by 2, okay, so, and that will give us 48. So the 48 and the 49th element will be added and divided by 2, and that's going to give us 150 plus 302 divided by 2. So how do we get the 48th element to be 150 and the 49th element to be 302? That's not so difficult. So let's see how we can do that. Actually, we can obtain that. Let me change the color of this one to make it easier for us to follow. Okay. Now we can obtain that by looking at the table. We know that, okay, from here going by this, the 48th element is 150. So you can see that. So when you're listing the elements, the 48th element is going to be 150. And the 49th element is going to be 302. You can look at it. Okay, so logically, 150 plus 302 divided by 2 is what we're looking for. So we get 226. Okay. Now how do we get Q3? All we need to do is just move in descending order. So we start, 503 will be our first element. And so 503 happens to, or we will repeat, sorry, 501 will be our first element. And we will have to repeat it. 501 will be repeated. 501 will be repeated 43 times. So when we continue, so let's assume that we have repeated it 43 times. The 44th element is going to be 408, and it will be repeated 54 times. And so that means that by the time we repeat it, we keep repeating it, it will actually be the 48th element and also the 49th element. So we just say 408 plus 408 divided by 2, that will give us 408. Now, alternatively, if you don't like any of, or you don't like the approach I have taken, you can decide that you want a better way of doing it. So you can use the formula. Okay. Sorry, please. Okay. All right. So you can use the formula that I have on the board. What do you do? Just do the substitute, all that you need to substitute, and then it will give you 48.5. So the element in position 48.5 is what you are interested in. But note, okay, there is 48.5 will lie between two numbers, which will be 48 and 49. So it means that we need to get the because this is not a whole number, so we need to get the 48th element and the 49th element just the way we did before. And the 48th element happens to be 150, the 49th element happens to be 302. You know that from here. You can see that 48th element 150, 49th element 302, and then you divide them by 2, that will give you 226. So to get your median, all you need to do is substitute everything that you need to substitute here again, and then you get 97. So that means the 97th element is actually your median. So what do? You need to come to the table. Let's take it off a bit and check. And when you check from the table, the 97th element, so this is the 96th element. The 96th element is 302. And so the 97th element is going to be 408 rather. And so that means your Q2 is 408. And then you can see that Q3, okay, so you substitute again, Q3 will be the 145 point, okay, the element in position 145.5, and that lies, but 145.5 lies between 145 and 146. So you need to get element, the 145th element and the 146th element. And when you come here, you can see that, okay, that should be 408, because 408 starts from position 97, and it will be repeated 54 times. So this is the 96th element is 302. So 408 will start from the 97th position, and it will be repeated 54 times. So that means it will continue until it gets to position 150. Before 501 will take, we continue, okay, the journey. All right, so to say. And then it means that 408 plus 408 divided by 2 will be 408. So that's how you get your quartile, or you obtain your quartile. All right. Now, let's look at group frequency distribution. Now, if you want to obtain the quartile for a group frequency distribution, it is actually similar to the way you would do it for an ungroup. Okay, no, it's similar to the way you obtain your median if you want to obtain the quartiles. Don't forget that the other quartiles were not discussed before now, but we discussed how you get your median for your group frequency distribution in a previous video, one of the previous videos. Now, look at this. This is actually the formula for your median, but we can change it a little bit to look like this. And the reason why I have done this is because it will be useful in explaining how, okay, it will be useful in relating this to the formulas for your Q1 and Q3. So what are we doing here? Actually, N summation F is the same thing as N. Now, since you have known that, and that is, in this case, is going to be 15. So since we know that, we just say N divided by 2 is the same thing as summation F I divided by 2. And how is that? Look at this. Now, if you say 2n divided by 4, 2 we cancel 2, that will be 1. 2 we cancel 2, that's going to be 2. So n over 2. And that is how we obtain 2n divided by 4 here. And so, since you know that, you may be able to see a similarity between that and the formulas that we actually used here. So you notice that not the n plus 1 now, but just look at, okay, yes, not the n plus 1 now, forget about the, except for this, forget about the n plus 1 now. But if you see, if you look at this, you have n divided by 4 multiplied by 2. So that's the same thing as 2 over 4. Okay, so, and that 2 over 4 is what I'm interested in. So looking at that, that applies to your formula here. So because you are interested in the second quartile, you put 2 over 4 here. If you are interested in the fourth quartile, you would have said 1 over 4. So let's go to the formula. Okay, we'll come there shortly. So how do you obtain your median again? This has been done before, but look at it. You say n divided by 2 is equal to 7.5. So that's what we have here. So you check your table, obtain the cumulative frequency, and then you check, where do we have 7.5 for the first time? Like a number that is at least 7.5. So at least 7.5, we have that here. So 7.5, and that means this is going to be our median class. Now that we know the median class, we need to obtain the lower, okay, class boundary. So the lower class boundary will be this 4.5. How did we get that? 4.5 here, the lower class boundary. So then we go on. What is the cumulative frequency of the class preceding the median class? So we need to know the median class, and we actually have known it. So this is the cumulative frequency of the class preceding the median class. This is the class preceding the median class, and the cumulative frequency of the class preceding the median class happens to be 6. So we have 6 here. And then what is the frequency of the median class itself? The frequency of the median class itself is 3. That's why we have 3 here. And then the class size or class width is actually 4. So we have that. So we substitute everything and then we get 6.5 when we are done. All right. Now, looking at that formula, let's look at that particular formula. Okay, let's look at the formula for Q1. Now, Q1, the same table I repeated before, is what I brought here. So it will be easy. It will be easier for us to do the work. All right. Everything that we did in our Q1 applies to, in the Q2 applies to the Q1. The only things that changed actually, so let me see, copying this will help us somewhat. Okay, so the only things that changed are the notations. So don't forget that I actually changed this to n. So we'll put n here, and I call this 2 over 4, and it's still going to be the same thing as what we had before. Now this time around, we are doing 1 over 4 multiplied by n. That's n over 4 minus. So this one was the cumulative frequency before the median class. This one is the cumulative frequency before the class that, before the class that contains the first quartile. So the class, so if you permit me to say it that way, the class of the first quartile. Okay, so very similar. Then this one is the frequency of the quartile class. And this one is the frequency, lower class boundary of the quartile class. So let's go. Let's see how we do that. This time around, we will not be using n divided by 2, but n divided by 4. So, and that's coming from here. Don't forget, just the way n divided by 2 came from here. 2 divided by 4 is going to be 1 over 2. And 1 over 2 multiplied by n is n divided by 2. So we say 15 divided by 4, that will be 3.75. So where do we have a frequency of at least 3.75 for the first time? And that happens to be here. So what do? That means our quartile class is also the class that contains the median. So the quartile class is this. And then we'll go on and say, okay, no. Sorry about that. It gives us 3.75. So 3.75, okay, where we have a cumulative frequency of at least 3.75 for the first time is here. So our quartile class is actually this one. Okay, that means the class that contains the first quartile, So that way, we will take the lower class boundary of the class that contains the first quartile to be 0.5. That's it. That's the correct thing. So we go on. What's the cumulative frequency before this class that contains the first quartile? Well, there is nothing that comes before, so we just take it to be 0. So nothing comes before it. This is the cumulative frequency of the quartile class, but there is no cumulative frequency before this particular one. So we take that to be 0, and then this actually should be Q1. So what is the frequency of the class that contains the first quartile? And that happens to be 3. So we say 3, looking at that again. Sorry, this is the class that contains the quartile. So what is the frequency of that class? It's 6, actually. So we are going to write 6 here. And then we have the class size before again. So let's do it again. we first say n divided by 4, that will give us 3.75, and 3.75 will be obtained in the cumulative frequency for the first time using the less than frequency when you are in this class. So we are saying a cumulative frequency of at least 3.75. Where's the first place that you are going to have it? It's here. So that means this is the class that contains the first quartile. And then the lower class boundary of that class is 0.5. That's how we got this. And then the cumulative frequency before that class, the cumulative frequency preceding the class that contains the first quartile, there is nothing that precedes this. So we actually just write 0 there. If something preceded, let's assume the first quartile class was here. The class for the first quartile was here. And that means the frequency that, cumulative frequency that preceded it, okay, would have been 6. But in this case, it's 0. So what is I'm talking about this base. So cumulative, this base. So if there was a frequency that preceded this one, we would have written it, but nothing precedes this one. So we will have to write 0 here. So, but what is now the frequency of the class that contains the first quartile? That happens to be 6 here, this one. So we'll take that and write 6 there. So we have 4 as the class width or class size, which you can see from here. So we'll substitute everything and then we get our answer. So when we come to the case of the third quartile, it's similar. So I would like to take a few things. Let's take this one. Let's see. Okay. All right. So look at our table again. Okay. All right. Let's see. All right. So if you substitute everything for the Q1, you do accordingly, you get 3. So looking at this, Q3 actually follows the same pattern. So this time around, we are interested in using, or we'll be using 3 over 4 multiplied by n. So 3 over 4. When we're interested in Q2, we use 2 over 4 multiplied by n. So, and when we were interested in Q1, we used n divided by 4. So that's 1 over 4 multiplied by n. And so when we look at Q3, what we are going to have is, okay, this formula here. And so looking at Q3, we say 3 over 4 times n, and that will give us 3 over 4 multiplied by 15, because n is 15, and that will give us 11.25. So where do we have 11.25 for the first time? We have that here. No, we have that here, rather. So not in 11. We have that for the first time here. So since 11.25 is greater than 11, and so that will mean that the lower class boundary, that means the third quartile will be in this class. And so since this is the class containing the third quartile, our lower class boundary will be 12.5, and that's what you see here. And then we will have the cumulative frequency before the class containing the third quartile to be 11 here, and then we will have the frequency of the third quartile class to be 4, and that's because it's actually 4 here. And so the class size or class width is actually 4 also, so we have 4 here. And so when we substitute everything as we should, then we are going to have 12.75 as the third quartile. Alright, so that being said, We'll continue in the next video.